these are just some of the design considerations I thought I'd just share with regards to the goblet. Modelled in SolidWorks. I originally shelled it just to give an outline without the inner sort of cup section. But then, sort of third revision down the line, I did a cut revolve on there and set it up for a thickness at the top here of 0.8 millimeters. My intention from the start was to print with a layer height of 0.2 millimeters. And the way the slicing works is that if I slice it with one shell, in effect it puts one shell on the outside and then it'll put one shell on the inside. So in effect you get two shells. And my average extrusion width at a 0.2 millimeter layer height is 0.4 millimeters, which is why I've set the cut thickness over here to 0.8 millimeters. So yeah, you soon get into the habit of actually thinking how these things are going to print and the best way of approaching it. Another thing I did, which I've doing a standard with a lot of stuff I'm printing, is doing my own rafts if I suspect that it may lift. Literally just print a single layer, solid about 10 mil, offset from the surface. It breaks away very, very easily after the print is finished. With this one it's actually even easier because it actually just touches. If you have a look there, you can see it just sort of touches, just fuses, but it held everything down great. I was having problems with the new filament, the clear filament, lifting and distorting on the base, and this really helped solve it. It didn't solve it completely because I had to make some changes with the actual printer and the heat settings, but this certainly helped. Okay, just some bits in Simplify 3D that I had to do to get this to print in the clear acrylic. Firstly, discuss build the raft. So basically it's a single layer of 0.2 plastic that's extruded. As standard now, I put at least 3 skirts on, just to make sure that the build plate is perfectly level. So by the time the third skirt is on, come round, if I haven't adjusted the build plate correctly, I cancel the plate, cancel the build and restart it. I'd carry on doing this and manually adjusting the build plate until I'm happy with those 3 skirts. Then I just let it print as standard. So nothing too complicated in here. The reason for the high percentage of infill is basically just to support the inner. I didn't want to go in there and start designing stuff, so I just put a 20% infill in to act like a raft, sorry, a support structure inside there. And as you see, as it gets up, we end up with 2 shells, which in effect on this edge will give us 0.8 millimeter thickness. So okay, that's a pretty bit done. I'll just show you some of my settings for this. Let's have a look. Cancel that. Right, so here we've got the extruder. It's the right extruder. So I've only got the one extruder running. 0.2 layer height, and these are the settings that I found are working quite well for me. Retraction distance, etc. Like I said before, for the right extruder, the layer height needs to be 0.2 millimeters. Ask for one top solid layer, one bottom, and one outside shell. What else? First layer is a bit slower, nearly 50% slower, and the height is reduced by 10%. I haven't included a raft because I've done my own raft. actually in the model, and I've asked for 3 skirts, and I'll keep the skirts quite close to the border of the print because that's where I need to get centered. Like I said before, no infill, so we don't have to worry. Sorry, of course there's infill. Excuse me, 20% infill, and that was just to support the bottom area here. I'm sure I could work out and fit supports inside internal supports, but I just took the easy way out and give it a bit more strength as well. Now this work gets a bit more interesting. The right extruder I had running at 230 for this filament, for the clear filament, and that's a constant 230. Now with the heated build platform, something new, I tried to correct the problem with distortion. Basically it's my view or my feeling that what happens in a print that causes these areas of distortion and the print lifting off the plate is basically because the temperature, once the bottom few layers have been extruded, the temperature is held constant by the build plate, and standard I was using 110 degrees. So if you think about it, that area is always held at 110 degrees. So it's extruded at 230 and held at 10 degrees for the duration of the print normally. By the time it gets up to the middle, there is a difference. I'm sure there'll be a difference of heat from that point where the extruder is there to the center of that point to that point. So if you think about it, this point's coiling is so that the temperature of this area of the print, no matter what size, is cooling and drops below the temperature of the build plate or the plastic that's on the build plate. Then was my belief or my thinking that the contraction, this area contracting, is what's pulling up the plastic of the build plate. Now, I haven't really tested this out, but I'll be doing a lot more of this. And my first attempt and my first thought of it has actually worked. It worked off the mark first time. So maybe that's something people can consider if they're having problems with their prints, lifting the corners, etc. Now, I've always wondered if it's warm down here and the plastic's a little bit softer down here. In the middle of the print, when the extruder's at the top here, obviously it's nice and hot at the top because it's extruding, and that area is still hot. But this area would have cooled down and contracted. So that contraction, I believe, is what's causing a lot of my issues anyway. I've only tried it. This is the first time I've tried this sort of strategy to combat those problems. So if we look at the temperatures on the build plate, so my starting at layer 1, I'm starting at 115 degrees. Layer 5, the temperature drops to 110 degrees. Layer 10, 105. Layer 15, 100. Layer 20, 95. And then layer 90. Sorry, layer 25, the temperature drops to 90, and it holds 90 then for the duration of the print. And that worked really, really well on the first attempt. It just solved majority of those problems I was having with things lifting and curling, particularly with this filament. The other thing I did to the actual Makerbot is I swapped the fans. I put new fans on the extruder. On the extruders, I had a recommendation from someone on RC Groups, and they kindly gave me a link to the fans to use. Brilliant, absolutely brilliant, very, very quiet, and I noticed the difference immediately, especially with this sort of very tight tolerance with the heat creep issues. The other thing I did was I used thermal grease between the heatsink and the aluminium block on the extruders as well, to try and make sure that as much of the heat has been absorbed into the heatsink and then therefore cooled. So that helped. And the last thing I did is I printed, which normally you wouldn't do with ABS, I actually printed with the door open and the lid off and a fan blowing into the cubicle to try and keep things cool in there. And like I say, it worked a treat. It worked really, really well. I think possibly I could go up a little bit higher on my temperature for my extruder. My actual extruder temperature could probably go up 5 degrees, just to diffuse things a little bit better. Not that it's a big issue. So anyway, those are the big changes I had to make to get this to work with this particular filament. I will be trying this with PLA, which I haven't had any success with previously with the Replicator 2X, and I'm really looking forward to seeing how I get on with just literally trying the fan, playing on the part that quite a few blokes are using now, and seem to be finding quite successful. So I'm ready to give PLA another go.